Hello everyone and welcome to this next video in the series of tutorials for the CAD NX practical course. Today we are skipping some parts from before because I think all of these parts before, that was the last one we did, are nice to do, so definitely do them. They all have their special things and are definitely good to have done for the exam. But I think there aren't so many new things that I have to show it to you, or especially hard things to do. Of course, this part is a lot to wrap your head around. There's a lot of drawings and everything, but if you do it step by step, you will get a really nice feeling and routine of the program and the whole thinking in 3D. So that's definitely a nice part to do. All of the parts are, but if this is kind of discouraging you because it's so big, I want to encourage you to still do it because you can really repeat what you have learned so far in a nice way. Maybe a little tip: start with, or I would suggest that you start with this kind of base right here, and then you can construct all of the parts on top of that, so to say. And the next two parts are very easy. It's just important to realize that these are round elements. You can see here, that's the vision from this side. So if you look from this side, that's how you see it. And here the same, that's how, if you look from this side. So make sure that you don't miss that these are round. And that one is pretty easy. Here maybe you just have to imagine how to use the details. A little tip: that one I would do with extrude, and that I would do with revolve or with sweep along guide even. Maybe you can do something with these tips. And this part is the one that we want to look into today. I think it's pretty easy to see, and the technical drawing might not be the biggest issue of this part, because we can see it definitely has this base structure again, and then it has some attachments like these knobs, these three, and this hole. So obviously we start with doing this, and then we can concern about the other parts. And to do this base, we also have a very nice view right here, which looks from the front and shows us everything we need to know to do this first part. So let's start a new sketch and start drawing. You could do this in two ways, I would say, and I'm not sure which one I think is better. First one would be only taking half of this thing and then then mirroring it so that you have the other half, that you don't have to draw the other half, or you draw both halves. And I think I will do the let's draw both halves, I'd say. But one thing that we still have to think, or actually no, I changed my mind again. I want to do just half for sake of maybe a little bit shorter video, and also to show the mirror function again. Maybe that's didactically a better idea. And the thing that we have to think about right now, though, before we can start, is where we want to put our middle point. And I would say it's not too important for that one. Of course, that should be the middle line. That's pretty obvious, because then mirroring gets easier and everything is nicer. And the middle point, I would just say that it's this right here, because you can see 40 millimeters is the dimension of this straight part, and 20 millimeters, half of it, is right here, where a radius starts. That's not the same as the middle point of this round thing, but that's no big deal, because we will model that later on. That's not part of this sketch, because that's a different extrude. And right now we are not concerned about that one, and that's why I would say that we will want to have our middle point exactly here. So, starting from here, I'd say we just go up. And I'm not sure. Yeah, okay. Yeah, 40 millimeters it should be, I would say. Because you see, the radius is 40 of this arc. So up here until our middle point, which is that, should be then 40 millimeters. So I'm starting with a line of 40 millimeters right here. Then I'm drawing an arc with the radius of 40, but I'm not giving it yet. Then we need a second arc, which goes in the other direction. So you see we have that. And then, let's maybe we can already move it a bit more in the direction where we need it. And then we need a line, which is going to the right. That line right here in the sketch. Then we need to go down and go onto here. No, actually we don't need to go onto here, we need to go further. Exactly 40 millimeters down. Then we have to go to the left. Let's say 27 millimeters as it's given. We go 10 millimeters up. Somehow to the left, I want to give this dimension later. 10 millimeters down. And then we need to do again 1 and 2 arcs. Okay, like that. And now, this, remember we haven't given this dimension. That's the 45 that can help us with that. And I want to select just this, and now type in 45. Of course, we could have just calculated in our head 45 minus 27, and then we could have given that before, but I'm let me decrease okay, like that. Okay, so now we already have, well, a rough shape at least, which looks pretty similar, but it's definitely not perfect yet, because we need some more stuff. Wait, let me delete that again, because we don't know this so far. And what we need is a little bit harder to do, but definitely something that is a nice trick that you need to know. First of all, remember, as before, tangency constraints between arc elements. So we have these two arcs right here, of course, and the tangency as it looks is already there, and let's say also here we have a tangency, but obviously here we don't have one. Here we have a little unsmooth part. So let's select both and click on the tangency and on OK. Now I'm not sure if this is horizontal. It looks like it would be. Yeah, it already was horizontal. Nice. And now we need one more thing, and that's something that's we only have this difficulty because we drew only half of the part. If we did the whole part, it would be no problem. But now we also need to establish that these arcs are exactly meeting this line in a perpendicular angle, so that that basically they are tangent to a perpendicular line that would be here. So I'm drawing a line right here, making it horizontal. That's important, of course, and making it as a reference line, because we don't want to have this line later when we extrude. And now we can make these two tangent. And we can do the same down here, like that. Make sure that this line is horizontal again, but okay, that one already is. And now we're selecting both and making them... Oh, okay, so that was the wrong way. So let's make it horizontal again. And now, of course, make it to a reference line. And now you can see it already looks better. Sorry, but definitely not good. And one of the problems is that radius right here is not starting where it should be, and it's also not the radius that it should be. So let's first make it 40. Like that. And maybe that already fixed it. Yeah, looks good, because you can see when I select it, we see the start, middle, and end point, and also down here we see the arc center. And this arc center lies directly in our center point, and that's what we want, because we have it here. As you can see, we have if you remember in the beginning, we have done our sketch like that, exactly for that purpose. One more thing that's not correct is that line should be exactly in the middle of this one. We can delete that line for now, I guess. Oh shit, we can't. Okay, let's not delete it. So the distance from here to here should be only 20. And then from here to here we also need to have 20, which is already inferred, of course. So that was one more step that we needed. And now you see we more and more get to the shape that we want. But it's not as straightforward as before, and that's why I'm showing you this part, because you have to do some thinking, like with these tangents and everything. So still, you see it's not defined completely, and that's because we also need to do the radiuses of these right here, and you can see it's 40. So if it's 40 here and the thing is mirrored, so to say, then you can then that will be 42. Okay, so we need to do a radius of 40 right here. And yay, we got 2 more black lines. That's what we want. And down here the radius is 30, so we can also make that a radius of 30. Nice. And now, what's the radius of this? We see it's 70, and that's a bit tricky because this radius starts 2 millimeters above the upper rim. So let's take that and make the radius of 70. And you can see 72, sorry, right? No, the radius is 70. But here we have to also keep an eye on the arc center, and the arc center is here where it shouldn't be, because you see it's below this line, but it should be above. So let's take the arc center, drag it above. Oh, and it's not enough to just drag it. We always have to give measurements. So let's say it's in a distance. Come on, of 2 millimeters, because 22, and that's 20, to the line which is 20. Okay, and now let's check if it worked. Looks good. Okay, so now we also have that, but still there are some brown lines, and now I have to be okay, I know what's missing. We haven't yet defined this distance right here, and that's 170 divided by 2, because you can see 170 is the whole thing, we only do the half of it. So right here we have to do 70. Come on. 70 divided by 2. Remember, you can just write this in here. And now it says the dimensions could not be edited as requested. Try relaxing dimensions and or relations. Okay, that's weird. Because now something's blocking us to change this. And I'm not sure what it is, but we can try to do what the program said to us and relax dimensions and or relations. That's what we can do up here. So let's try that again, but this time we click on relax dimensions and let's try both relax relations. Now do 170 divided by 2, and now it did something, but you can see what it did. It changed some of the dimensions that we gave before. That's what it did, and it did that because we relaxed dimensions. That means that if we change another dimension, that's the top priority basically, is to change this dimension, and the other dimensions can be relaxed. And that's not exactly what we wanted, but at least we have this now, and we can try to change them again to what they should be. And that seems to have fixed it. As you can see, that point of the program, I have to be honest to you, I don't understand since it's new. So I don't understand what sense it made now, why it changed those dimensions, and I could change them again now, and now it's correct. I don't know why the program is not smart enough to realize that that's what we want. But now everything looks perfect, at least, and that's an important learning for you probably, to use these relax dimensions and or relax relations functions. Again, relax dimensions. Dimensions are these millimeter dimensions. Relaxes them, so they can be changed. Relax relations says that relations, like, the tangency constraints, the point and curve, horizontal constraints, vertical constraints, all of the stuff that you do up here can be changed. Probably I'd say relax relations is enough often if you want to change something, but if you use one of these two functions, then do like I did right now, and afterwards always check what has been changed and if that messed up what you actually want. Like right now, where it messed up these two dimensions. The rest still looks perfect to me, I would say. So, and because our sketch, it says sketch is partially defined, but I think that's just due to our two, you see the only brown lines are these, and I think they are missing lengths, so let's just for the sake of having it fully defined, give them lengths, but in this case, of course that wouldn't be a problem because these are just our horizontal references, so they don't need to have a length. Come on. Okay, so now the sketch is fully defined. We can go out. Now I'm extruding, and let's see how much or how far we need to extrude. Where can we see that? We can see that here. 40 should be the distance that our extrude should be. Okay, so that's it. And now we can mirror it. And because we have drawn it exactly in the coordinate system again, we can just use the x and z axis as a mirror plane. But I want to show you something else in case you don't do it like that, which I still always suggest that you do it, or recommend that you use the given coordinate system. But if you can't, then you can just select a face of the part itself, and then it mirrors it along this face. Now I want to unite both, because mirroring doesn't automatically unite usually. So they are united, and now we have our base structure. The other parts aren't very hard to do, I guess. I mean, here we would have to draw just a round sketch and extrude that and subtract it, so we have the hole in the middle. Also the round plate in the middle is no big deal, I would say. Maybe the only thing that might be a little tricky is these knobs, and that's why I want to do one more thing in this video, and that's these knobs. I would leave out the other two parts if that's okay for you. I hope it is. So let's draw a new sketch, and now I'd say we do it just on top of this plane and take the coordinate system in one of the edges. And now let's see what we have. We know that it's 5 millimeters high. That's nothing we have to concern about now, because that will be part of the extrude function. And we have a radius of 2 millimeters, height of 20, width of 15, and distances to these two lines. So that should be pretty easy to draw, I'd say. Let's just do a rectangle, and I'm not giving it any measurements yet, because I think it's way easier to just give them now. 10 here. Yes, why not? Okay, not didn't help a lot. Whatever. 10 here. And now that should be 15, and that should be... Come on. Jesus, it's again... so let's try again with relaxing the relations. 15. Okay, now it worked. And also, let's do 20 here. And I would say that's already it. We're just missing the round edges. And we can do them now by taking the fillet function, using or grabbing one of the edges, giving a radius of 2, and then doing it with the other ones. You can also grab the two lines which are meeting in the edge. That's also possible. Or the point of the edge with that function. Okay, and the nice thing about the fillet function is it already gives all of the tangency constraints and everything, other than if you would do it with an arc. So if something like this, I always recommend to use this function and do a simple rectangle before. That's most of the times the easiest way to do it, I guess. So now we have this where it should be. We use the extrude function. We know that the height is 5. But the angle that we need to do separately or differently. And I'm not sure if you have used it before, but you can find the function to do that. If you click on this little arrow, on this more arrow down here, and then you go to draft,